Hello, let's talk about the homologous series of alkanes. Homologous series of alkanes. The word homo is a Greek word that stands for the same. Logos stands for structure, relation, proportion, series, sequence, or in succession. Alkane is a functional group in organic chemistry that has the names of each member ending in "ane", and they are all saturated hydrocarbons. So when you hear the word homologous series of any functional group, it's trying to define a group of compounds that are in succession after one another. So homologous series of alkanes are compounds that differ by a repeating unit known as a methylene, that is CH2. For example, let's look at the first 5 homologue in alkane. Now, I use the word homologue. This is because every member of a homologous series is called a homologue. Now, the first member of the alkane family is known as methane, CH4. And I made mention earlier that the next member differs with the first member by a repeating unit known as methylene, and methylene is CH2. So remember, the homologous series means they are the same compounds or similar structures that differs by a repeating unit. So that means if I add CH2 to CH4, it will give us the next member, and if I add CH2 to this new member, it will give us the next member. If I do the same, it will give, we can see that addition of CH2 to methane gave us the next family member known as ethane. Addition of CH2 gave us propane, butane, and pentane. And if you observe that these number of carbons follow the serial number here, that is why homologous series share the same functional group, meaning that it's either you're adding CH2 to the previous ones or using these numbers and substituting in their general formula, you can get the succeeding member of this homologous series. So tell me, when you add CH2 to pentane, what do you have? Okay, so the next would be hexane, which is C6H14. So let's look at the general formula. The general formula of alkanes is CnH2n plus 2, where N stands for the number of carbon atom present in the molecule. And remember, I told you earlier that the number of carbons correlates with these serial numbers. So this is carbon 1, just indicating 1 carbon present in this compound. This 2 tells us that there are 2 carbon in this. This 3 tells us that and they are relating with this. So using that serial number, let's find out the members of the homologous series of alkanes using the general formula. For methane that has 1 carbon, substituting the number 1 into N, we have C1H2 in bracket 1 plus 2. And you know, this bracket indicates multiplication. So C, since it's 1, we don't necessarily have to write 1. 2 times 1 is 2. 2 plus 2 is 4. Hence CH4. So quickly, let's do, using this formula, let's get out the first 5 members. Okay, I know you guys are smart, and I believe we all got the same answer with mine. If you didn't, you can correct yourself and practice. And with this, you can know the entire family. Just follow the rules of the formula or the repeating unit. So let's look at our take home. Remember that homologous series are molecules or group of molecules that differ in the number of methylene groups because they share the same functional group. Each member shares similar, not the word similar, not the same, chemical properties, but varies or experience a gradation in their physical properties because of the increase in their molecular mass. Each member of the homologous series is called a homolog, and the general formula of alkane is CnH2n plus 2. So once again, the difference in the molecular formula between one member and the next, say with me, is CH2. Thank you for watching this video. I hope it was helpful. Look out for the next video on the homologous series of alkenes. Don't forget to subscribe, to like, and to share.